Welcome to the another class. So today we will solve a numerical regarding Thevenin's theorem. So you can see that in this question they asked obtain Thevenin equivalent circuit at terminal A B of the above circuit. So circuit is given, so there is no load resistance is given. So they asked what is the Thevenin equivalent circuit at this terminal A and B. Okay, so in each case, to find out Thevenin's theorem, first we need to find out R Thevenin. Here load resistance is not there, so no need to remove the load resistance. Load resistance is removed previously from the beginning. So we start from the what is the equivalent resistance between A and B. So when we will draw the equivalent resistance, at that time, what we have to do? We have to make the voltage sources short circuit and current sources open circuit. So you can see here I made voltage sources short circuit and current sources open circuit, and I need to find out the resistance from this AB side. So when I look from this AB side, you can see 10 and 10. So these two are in series. Okay, so and parallel with 5. So I can write down RAB equal to 10 plus 10, it is 20, parallel with 5, and whatever I will get now, that is series with 16. So I will get 20 parallel with 5, I will get here 16. So I will get 4 plus 16 equal to 20 ohm. So I can write down RAB or R Thevenin, I can get R Thevenin equal to 20 ohm. To find out RThevenin, it is very easy. So one thing you need to remember, voltage sources will be short circuited and current sources will be open circuited. So once you get the RThevenin, then we can move to the find out VThevenin. So when we find out VThevenin, we need to draw the circuit again. So I can see here I have drawn the circuit again by putting all the voltage and current sources. Now I need to find out what is the voltage between A and B. So I want to find out VAB, that means VA is having higher potential and B is having lower potential. So I'll put at A and B. So now I can see if this node is A, I can say this node is also A and this node is, if this node is B and this is the same node, so this is also B. So I need to find out the potential difference between A and B. So in many ways you can solve, but for simplicity I am taking here mesh analysis. I am taking here mesh analysis. So I am taking here mesh analysis. So think that this is two meshes here. This is I1, this is mesh number 1 and this is mesh number 2. And here current is flowing I1 and here current is flowing I2, and both are flowing in the clockwise direction. So if I will write this mesh equation in the first mesh, then I will get here minus 2. So current will flowing like this. So here it will be plus, it will be minus, and here I1 amount of current is flowing. So when it come to this 10 ohm resistor, so when it will come to the 10 ohm resistor, you can see. So this 10 ohm resistor is common to mesh 1 and mesh 2, and here current will be flowing I1 minus I2, and the direction I have mentioned here. So current is entering here plus, leaving here minus, and in this 5 ohm, so similar I1 amount of current is flowing. So current is entering here plus, leaving here minus. So by applying KVL, so if I apply KVL here, KVL, so I can write down minus 2 plus 30 volt minus 10 into I1, then minus 10 into I1 minus I2, then minus 5 I1 equal to 0. Okay, so this is the equation number 1 I will get, and if I will apply the mesh analysis in this second mesh, you can see here I2 is flowing in the clockwise direction, but 5 ampere is flowing in the anti-clockwise direction. So both we have the flowing in the opposite direction. So directly I can write down here I2 equal to minus 5, this is equation number 2. So you can see I2 is flowing in the I2 I got minus 5, that means my assumption is wrong. So I2 is flowing in the opposite direction. So by putting equation number 2 in equation number 1, by putting equation number 2 in equation number 1, I can find out I1 value equal to I1 value equal to minus 0.8 ampere. So just simplify this equation, you will get I1 value equal to minus 0.8 ampere and I2 value equal to minus 5, that is given from this equation. So you can see here I1 and I2, I am getting both are negative. That means my assumption is wrong. Current actually flowing in the opposite direction. So I1 is flowing in this direction and I2 is flowing in this direction. Okay. So if current I1 is flowing in this direction, so here I will get actual. So current is entering plus, leaving here minus. Similarly, in this 16 ohm resistor, this current will enter here plus, leaving here minus. So now if I1 amount of current is flowing here, so what is the drop here I will get here? Drop equal to the 5, the current into resistance, 5 into I1. So I will get here 5 into 5 into 0.8. So this is not minus 0.8. So I am taking the actual current direction. I1 equal to minus 0.8. So current is flowing in the opposite direction. So I will get here 4 volt. So you can see 4 volt, but this one will be plus, this one will be minus. Similarly, I2 is flowing from the left to right here. From the left to right, you can see the arrow mark, and here current is actually 5 ampere. So the drop here, I can find out the drop here equal to 16 resistance into the current, 16 into I2, or I can write down 16 into 5, this will be 80. Okay, so I will get this is the 80 volt. Okay, so now if I want to draw this above, if I want to draw this or redraw this one, so like you can see here, I will redraw here. So this will be your A, this will be your B. So this is your 5 ohm, this is your 16 ohm. So current I2 is flowing in this direction, current I2 is flowing in this direction, current I1 actually flowing in this direction. Okay, so actual current, because I got the negative value. So here the drop is, here the drop is 4 volt, this will be positive, this will be negative, and here the drop will be, here the drop will be 80 volt, this will be plus, this will be minus. Okay, so now I can get VAB. So if we will apply KVL here, if we apply KVL here, this will be VAB, this will be plus, this will be minus. I want to find out VAB, so I will apply KVL here. So I will go plus to minus, so there is a drop minus 4, then again plus to minus, so this will be plus, this will be minus, plus to minus, this is minus 80, then again plus to minus, I will get VAB equal to 0, so I will get VAB equal to 84 volts, or VAB equal to minus 84 volt. That means I will get V Thevenin equal to minus 84 volts. I got V Thevenin minus 84 volt, and I got previously R Thevenin equal to 20 ohm. Okay. So now I will redraw the circuit. So I will write down here. This is your V Thevenin. This will be your R Thevenin, and this terminal is A. This terminal is B. I will write down here V Thevenin equal to minus 84 volt, R Thevenin equal to 20 ohm. I can write down in this manner, or I can do like this. So I can put the battery source in the reverse order. I can write down this is plus 84 volt, and this is your resistance 20 ohm, and this terminal is A, this terminal is B. So both the answers are correct. I hope you understand this lecture. If you have any query, you can write down in this comment section.